Okay, for this next lesson, hopefully you downloaded this worksheet, lesson 1.6 applications of linear functions, because this is where I'm going to do all the examples, front and back. This is going to be very helpful. Hopefully I'm giving you all the different types of examples you'll have for homework tonight. So sometimes when working with equations, you might want to draw a diagram. For example, modern televisions often have a 16:9 aspect ratio. This means that the length of its rectangular screen is 16/9 times its width. If the perimeter of the screen of a Samsung model having this ratio is 150 inches, find the length and width of the screen. So if I want to draw myself a little picture right here, okay. No, it seems silly, but it's always helpful to start that off. And it'll say, then you kind of go back in the problem. This means that the length is 16/9 times the width. So if I called the width W, this length would be 16/9 times the width. And if we're talking about perimeter, I can walk myself around 16/9 W. This side would be also W. And I can add all of those up. So I would have, let's see, 2W plus 2 of the 16/9 W, and we were told it equals 150. So 2W plus 32/9 W. And again, we just learned from the last class how to get rid of fractions inside of equations. So you can multiply everything through by a 9. So multiply this by 9, this by 9, and this by 9. And you'll just clear those fractions. This would be 32W, and 9 times 150, I'm going to use my calculator, 1350. And so then that makes it 50W, and then you can divide by 50 and get width to be 27. So if your width is 27, then your length right here would be 16/9 times 27. And I'm going to get 48. So drawing a diagram helps. All right, some motion problems. Ooh, these are so much fun. So I make charts for the rest of these problems here, motion and mixture problems, and I'll show you how to make this chart. Manuel traveled 2 hours nonstop to Mexico, a total of 70 miles. He took a train part way, which averaged 40 miles per hour, and a bus the remaining distance, which averaged 30 miles an hour. How long was he on the train? Okay, so if you remember the good old phrase, rate times time equals distance, or maybe you said distance equals rate times time. So I use that to draw myself a little chart. We're going to write his rate here, his time here, and his distance there. Rate times time is distance. We know that on one part of the, I don't know what my son watches. No, I do. He watches some Ninja Kid stuff. This is a train that he took part of the way. The other part of the way he took a bus. Okay? And now we're going to fill out this part of the table. So Manuel traveled 2 hours nonstop to Mexico, a total of 70 miles. He took a train partway, which averaged 40. So the train was 40 miles per hour. The bus averaged 30. Now, we know that he traveled a total of 2 hours. So we can call one of these X. And since we're trying to find how long he was on the train, let's call that X. The other would be, again, these two together need to make 2 hours. So I would need to call this 2 minus X. So maybe he was on here for half an hour or a tenth of an hour. We don't know, or maybe 1 hour. That's where I would get this. So I take the total 2 hours minus how much he was on the train. Now multiply these across. 40X, 30 times 2 minus X. And then let's talk about distance real quick. So if here's Manuel and he travels by train, and then from here he hops on a bus, and then here he hits Mexico. we do know the total distance is 70 miles. So we know that this part plus this part would make 70. 40x plus 30 times 2 minus x equals 70. So 40x plus 60 minus 30x equals 70. 10x plus 60 equals 70. 10x equals 10. X is 1. So we know that if x is 1, he was on the train for 1 hour. He was also on the bus for 1 hour also, but since they asked about the train, he was on the train for 1 hour on the train. So motion problems usually make two different rows, and then 3 columns. All right, now mixture problems. You are going to have some mixture problems tonight. I'm going to show you the easiest way to do them. In this one, we're going to add pure alcohol, and here we're going to add water. I want to show you the difference there. So what I do for mixture problems is I actually create 3 rows. And in those 3 rows would be what you start with, what you're adding, and then what the new mix is. So you can think of it like that. Start, what you add, and then what your new mix is going to be. So how much pure alcohol should be added? So we are adding alcohol. How much should be added to 20 liters of 40% alcohol? So we have this 40% alcohol solution, and we're going to increase it to a 50% alcohol, because when you add alcohol, it increases the alcohol aspect of it. I was going to say alcoholicness, but so now when you go to do these mixture problems, you always have a percent times an amount equals a total. Okay? The percent of alcohol in 40% alcohol would be 40%, or let's write it as a decimal, 0.4. The percent of alcohol in pure alcohol, well, that's 100%, because you're adding 100% alcohol, pure alcohol. So that would be 1. The percent in 50% would be 0.5. Move the decimal over twice. Now let's talk about amounts. They gave us some amounts here. Let's see. How much pure alcohol should be added? So that would be, how much of this pure alcohol are we going to add? Let's call that X. How much should be added to the 20 liters of 40% alcohol? So we remember we already had 40% alcohol. We had 20 liters of it. What would that do to this new mixture? Well, you would have 20 plus, we don't know how much we're adding, so we're going to call that 20 plus X. Now multiply these across. 0.4 times 20, 1 times X is 1X, and then 0.5 times 20 plus X. Now, your equation to set up is really easy. It would be these two together would make the new mix. So 0.4 times 20 plus the 1X would equal 0.5 times 20 plus X. And we just learned from the last video how to get rid of these lovely decimals. We multiply by the common denominator, or what position it's in. This is in a tenth. So we're going to multiply everything through by 10. So this gets multiplied by 10. This gets multiplied by 10. This gets multiplied by 10, this whole quantity. And what that 10 does to the 0.4 is it makes it a 4 times 20. This becomes a 10x. This 10 times 0.5 becomes 5 times 20 plus x. So you get 80 plus 10x equals 100 plus 5x. And then we just solve, and we get 5x equals 20, x is 4. So we're going to add 4 liters to our mixture problem. Okay, we're going to do another one of those, but this time we're going to add water. So things are going to be quite similar here. Again, I got my 3 columns. What do I start with? What am I adding? And what would my new mix be? So how much water? This time I'm adding water. Should be added to 12 milliliters of an 11% alcohol solution. And just so you know, it's not always alcohol that you're adding. You can add antifreeze. You could add, a mixture of I've seen peanuts and nuts to make trail mix and stuff like that. This time we're going to add water, and it's going to reduce the concentration to 6% because when you add water, it's not as alcohol-y. All right, and we got percent, and we have the amount, and it equals a total. So let's talk about this. What is the percent of alcohol in water? Well, there shouldn't be any. What is the percent of alcohol in an 11% alcohol solution? It would be 0.11. What's the percent of alcohol in a 6%? That would be 0.06. All right, so again, let's go back and reread this. How much water? So call it X. Should be added to 12 milliliters of the 11%. So 12 goes here. What goes here? Yeah, you just add these two together. The new mix should contain 12 plus whatever water amount we added. Multiply across. 0 times X is 0. Again, don't know what my son is watching. 0.06 times 12 plus X, okay? And then it's the same as above. You're just taking these two and adding them together to make that new one. So 0.11 times 12 plus 0 equals 0.06 times 12 plus X. And we're going to multiply everything through by this time we're in the hundredths place. So multiply by 100. You can do 100 here, but it's going to go away. So 11 times 12 equals 6 times 12 plus X. And you can easily figure this out. You get 132 equals 72 plus 6X. So what are we left with? 10, I think, yes. X equals 10. 10 what? 10 milliliters. You'd be adding. Okay. Last and final few things here. Just a little definition on direct variation. Number y varies directly with x if there is a non-zero number k such that y equals kx. This is your direct variation equation. So just real quick, an example right here in a table. You'll have a homework problem similar to this. If y is directly proportional or varies directly to x, find k when x equals 10. When x equals 10, we're going to find y. So we're going to find k. Then when x equals 10, we're going to find y. So first thing we got to do is find k. So we write our direct variation, y equals kx. And you can pick any point you want right now. I'm going to pick this first point. When x is 4, y is 24. So I'm going to put 4 in for the x, 24 in for the y. You could have chosen 7 and 42. It doesn't matter. But then you can easily see k must be 6. Okay? So now that we know what k is, we're going to rewrite this then as y equals 6x. That's actually the formula we need for this equation. So now we're asked the second part. When x equals 10, find y. So if x is 10, we're going to put 10 right there. 6 times 10 equals y. Y must be 60. So it's very easy to do. All right, solving formulas for a specific variable. Again, if you're really good at equation solving, this should be easy for you. And again, if you're in pre-calculus, you really should be good at equation solving. But we're going to solve for L. We're going to get L all by itself. So we're going to move the 2W over. So P minus 2W equals 2L. And then we're going to divide by 2. And you can leave it like that. It might ask you to rewrite it. You can rewrite the 2 underneath each of these. So P over 2 minus 2W over 2 is just 1W. Again, it depends on what the question, how they want you to write it, but either would be fine. This is your Celsius Fahrenheit. Let's solve for Fahrenheit. So I want to get rid, F is inside of a parenthesis, so I need to get rid of this 5/9. You can divide it out, which is the same as multiplying by the reciprocal, 9/5. So we're going to multiply this side by 9/5. And this will go away and leave you with F minus 32, and then add 32. I think on tonight's homework, they're not. I mean, they're just this simple, so hopefully it'll be easy. All right, one more word problem-y thing. Hopefully this hasn't been too hard. Similar triangles. One of my favorite ones, from geometry. A 5-foot person casts a 9-foot shadow. Again, draw it out. Help yourself out here. Label 5 feet. Casts a 9-foot shadow. At the same time, a tree. Here's my beautiful art skills. Casts a 38-foot shadow. Find the height of the tree. So what you're doing here is proportions. They're similar triangles. You can think of it like that. So you would write it again. It doesn't matter. You can write 5 to x equals 9 to 38, or 5 over 9 equals x to 38. You just want to stay consistent. 5 over 9 equals x over 38. Crisscross multiply. 9x equals, I got to do it on the calculator. I'm tired today. 190 divided by 9 is about 21.1. Repeating. And again, you can convert that if you need to, but very easy. Hopefully you'll understand how to do these mixture problems and motion problems a little bit better. Let me know if you have any questions. Bye.